So, today we are going to be talking about pattern searching or pattern matching. So, the setting is that we are given a piece of text, let us say T is our text, which is of length n. So, it is n characters over some alphabet. So, for today we will just assume that it is the English alphabet, and we have to search for a pattern P in this text. So, you all have come across this problem, right? You are using a certain editor, you want to find out all occurrences of a certain word. Yeah. Most editors will provide you this facility, your browser provides you this facility, many things will provide you this kind of a facility that you can search for a particular pattern, and not one occurrence, but all occurrences of that pattern. Okay. So, question is how are we going to do it? This is also the exact matching problem. There are versions where you can not do an exact matching, as in you can search for the pattern in an approximate manner. That means occurrences of the pattern in the text where it matches most of the text. Matlab, if there is a difference in one character, it is okay, or a difference in two characters, it's okay, but at most other places it matches. Yeah. So, how would one solve this problem? Okay, so what are the applications? This comes up in text editing, as you can imagine. It comes up in information retrieval. One big application is bioinformatics, right, where your text would be, let us say, large database with sequence of nucleotides in it, and you are searching for a particular gene or a particular sequence of nucleotides, and you want to find out where all they occur, right. So, this is an example where the alphabet that you have is small, right. If it is DNA, then the alphabet has just 4 bases in it, right, but if it is a protein sequence, then it has 20 bases, whatever 20, it is an alphabet of size 20. So, what is the naive method of doing this? So, suppose this is a text, yeah, and I have a certain pattern. Let us say my pattern is AG, right, this is the text. So, what do I mean by the naive method? I will put the pattern at the first place and I will start matching the pattern against the text, right. At the third place I find a mismatch. So, what do I do? Start again from the second element, the third element, or the fifth element? From the second position, right. Is it clear to everyone why I should start from the second position and not from the fifth position?
The pattern could be something different. We can have A pattern will be A.
Right. So, what we are going to do is move the pattern by one step. We will see examples of why this one step was critical and not more, right. So, clearly by moving it by one step, we are not losing anything, right. We will be able to find all the patterns, all the occurrences of this particular pattern. So, we do this, again there is a mismatch right at the very first step. So, we will move forward by one step. Again mismatch at the very first step, we will move forward by one step. Now, here you see there is a mismatch at the fourth position, right. So, how much should I move it ahead by? Still 1. Okay, we will keep moving by 1. Actually, yeah, you did not see, right, even here there is a mismatch, at this place there is a match, and so you will say that this is one occurrence, right. Does everyone understand why we are moving by 1? Okay, so this question, why we are moving by 1 and not by 4? Right. So, if we were moving by 4, we could have skipped this thing, right. So, suppose I moved at 4 at this position, then where would I end up at? AG here, and then if I moved at 4 again, then I would have end up with AG, and so I would have missed the occurrence of the pattern, because the pattern is not occurring at 4 multiples of 4 or any such thing. It could occur anywhere in the text, right. So, moving by 4 is the wrong thing to do. Okay, everyone understands this, good. So, how much time does this take? Mn, n square or koi m? Nm, why? Right, so for every position that I put the pattern, I might have to match up to n places. It might be that only at the very last place I find out a mismatch. in which case that I am matching it at all the places of the pattern. How long was our pattern? M positions or N? N positions. M, sorry. Pattern was M, right. So, we might for each location of the pattern, we might have to do M matches. And how many different positions of the patterns are there? N different positions, right. So, I might be spending as much as Mn time, right. So, the time complexity then is order Mn. Space complexity is also going to be an issue. How much space do we require? Is this clear that we require only M plus N? We just need to store the text clearly and we need to store the pattern. We do not need any other additional space, right. We do not need another array to move the pattern in it or any such thing. This moving the pattern is only to show it to you here. You can always increment your index appropriately. Yeah. So, this unfortunately is not too good. Why? Why is it not good? Too high, right. So, if you have a huge document, M is very large and your pattern is also reasonably sized, let us say 20 or 30 characters, then you are going to spend a lot of time, right. So, this is not the way it is done. So, we are going to look at another solution today, right, and we are going to look at a third solution in the next class. So, this will be a sequence of improvements. We will improve the time complexity today from Mn to something else and we will see what that is. Okay. So, how can we do better? So, when a mismatch is detected at a certain position, let us say at position k in the pattern string, what do we know? We know that we have matched k minus 1 characters before that, and we will try and take advantage of this fact that we have already matched k minus 1 characters, right. Let us see what I mean by this, right. So, here the mismatch is detected at position 3, position 3 of the pattern, right. So, what do I know? I know that the first 2 characters of the pattern are the same as the last 2 characters of the text. First 2 in this picture, yeah, the just preceding characters in the text, right. So, I can use this information to try and move the pattern not by one step, but by more steps. Why? Okay, let us look at this again. So, this is A, this is C, there is a mismatch here. Okay. So, what do I know? Even if I did not know what was here, I know since this is the mismatch, I know that here at this position in the text it is G and this position in the text it is A, right. Now, if I shift the pattern by 1 unit, what happens? I know that in this position in the text it is a G. Yeah, you understand why I know that? I do not have to look at the text to know that, although the text is here in front of you, you can erase these 2 things and yet you know that this is G and this is an A. And since this is a G, there is no point in shifting this one step, because then this would never match with this.
So what if the 2 are same?
What if the 2 are same? Yeah, then we'll have to shift by one step. If this were also
then
an
the
A,
mismatch itself will come at the second step.
right? If this were an A, then we would have shifted it by one step.
Mismatch itself would come at second step if it would happen.
तो दोनों A होते हैं, right? So that's the idea, and we'll see how to implement this idea, right? So we are then shifting it by an appropriate. Now again, what do we see? We see that there is a mismatch at the very first step. So कुछ नहीं कर सकते, एक ही step move करना पड़ेगा. एक step आपने move कर दिया. अब क्या हो रहा है? Mismatch at the fourth step, at the fourth position of the pattern, right? Now, should I shift it by one position? Should I shift it by 2 positions? Should I shift it by 3 positions? Okay. Now, what do I know? So, what I claim is you do not have to look at the pattern here. You know that the last 3 characters of the pattern are the same as these 3 characters here, because after all, you know, the mismatch was happening at this position, right? So, this has to be an A, this has to be a G, and this has to be an A. Right. Now, if I were to shift it by one position, then that means that यहाँ जो G था वो A would be here, so there would be a mismatch. If I were shifted by 2 positions, then I know this is an A, this is an A. Yeah. And what else do I know? I know this will become a G, but the G was already mismatching with this. Actually, I do not really know that. So this is right. So either I could shift it.
Dependent upon the pattern.
Depending on pattern.
Yeah, the shift will depend upon the pattern, of course, and we have to determine what the shift should be, right. So here it is completely clear that we would not want to shift it by 1 unit, right, but whether we want to shift it by 2 units or not, we do not know. I am shifting it by 2 units, right. So let us say we will shift it by 2 units in this case. We will see the exact procedure very shortly, right. That is what the purpose of this lecture is, right. Once again we see there is a match here and then there is a mismatch here, right. Okay. So mismatch is at the second position. So should I shift it by 1 position? I will shift it by 1 position. Again now I see a complete match, so there is nothing to be done here, but I have to continue, I can't stop. Yeah. Now how much should I shift it forward by? 2 or 4?
Can the mixed pattern?
What do you mean by split patterns?
Mixed pattern.
What do you mean by mixed patterns? Yeah, if there was another AG here, yeah, these are 2 occurrences then, right? This would be 1 occurrence and this would be another occurrence if this were A and G.
So they can intersect the pattern,
It's all occurrences of that pattern, right? I am not saying all disjoint occurrences of the pattern. Yeah, all occurrences of the pattern. So I should be shifting by 2 units. So I shift by 2. Where did it disappear? Sorry, it should have come there. So I would have shift by 2 there. So this is what is known as the Knuth-Morris-Pratt algorithm. It's a very famous algorithm. So key idea is when a mismatch occurs, we need not restart the computation all the way from the back, right? We can use some information about the pattern, some information obtained from the pattern to determine how many steps we should shift forward, right. And what we are going to do is we are going to construct an array H that is going to determine how many characters to shift the pattern to the right in case there is a mismatch. So we are going to store this information of how many characters we have to shift right in an array which we will call H, and we will see what this array H should be. Okay. So what is the key idea now? Okay, so I guess I need to explain it more clearly. So recall we have our text, we have a pattern, right, and we are seeing a mismatch at a certain position. There is a mismatch here. Okay? Yes? That means this is not the same as this. So suppose if we have successfully matched the prefix P1 through Pi minus 1 of the pattern with the substring Tj minus I plus 1 to j minus 1. So let us label these things. So this would be location j, this would be I. So I have successfully matched P1 through I minus 1. So this would be location I minus 1. I have successfully matched P1 through Pi minus 1 of the pattern with what part of the text? Well, j, so j minus 1, this would be j minus 1, and basically we are counting I minus 1 locations still here. So that would be locations j minus I plus 1 to j minus 1. So this is the part of the text which is the same as this pattern, that I know, because this is the first place where the mismatch happens. And Pi pattern, this is not equal to Tj, then we did not reprocess any of the suffix, right. So what we are saying now is that we need to determine how much we need to shift. So we should shift in such a manner so that, let me do it right here, we should shift in such a manner so that this part matches with this. right. So, now this is a shifted pattern. I need to shift in such a manner so that this part, these two parts are the same, right. These part match up completely. Why? Why would these parts match up completely? Because then this part would also match up with this here, because I know this is the same as this. Okay, I will repeat it with the next slide. Okay, so with each position of the pattern, we are going to define. So, recall we said there is this array H which determines how much we are going to shift the pattern by. What is the information HI? HI tells me how much I am going to shift the pattern by if there is a mismatch at position I. Okay? If there is a mismatch at position I, then how much am I going to shift the pattern by? Right. So, how am I going to determine, sorry, HI is the extent to which I will shift the pattern if there is a mismatch at position I plus 1. Okay, that is going to be the semantic.
It is the smallest shift that we do.
Okay, so we'll understand this in right. How much am I going to shift the pattern by? We'll of course try to make the smallest possible shift.
Otherwise we might miss some of them.
Smallest is one.
Otherwise we might miss some.
Smallest valid.
Smallest valid is under this condition.
Right, we'll come to all of that, don't worry too much, right. So, we are going to make a certain amount of shift, we'll see what the right shift is, okay. Smallest or largest, because it is both smallest and largest in a certain sense, right. Smallest so that you don't miss out on any pattern, largest so that you don't waste any comparisons. So, it is both a smallest and a largest shift, okay. So, you can pick, okay. So, suppose this is what is happening, this is my pattern, I am now not showing you the text at all, okay. But I tell you just the following information, that the mismatch happened at position 11, okay. So, you do not know what the text is, but the mismatch happened at position 11. How much should you shift this pattern by? Okay. Let us see, let us draw a picture and let us see how much you should shift the pattern by. 6 someone said, huh? Okay. Let us say I shifted the pattern by 1 unit, then what will happen? I will have A, B, A, A, useless, right. Why? I am now comparing the pattern against the pattern itself. Why? Because I know the text is the same here. That is what I was said, I do not know what the text is, but I know now what the text is. It has to be this. Yes? This is one key observation. So, now if I shifted the pattern by 1 unit, then clearly it could not have matched against the text. So, 1 is useless. Okay. Right. Let us shift it by 2 units. Okay, I should have kept all of this around. Let us shift it by 2. If I shift it by 2, I get A, B, useless. Right. Let me draw the shift by 1 also. A, B, A, useless. Shift by 2, useless, because this is not matching this. Shift by 3, A, B, A, useless. Shift by 4, A, useless. Shift by 5. So, I can keep playing this game, right. A, B, A, great, B, A. राइट सो हमने जब शिफ्ट बाई कितना किया था ये सॉरी 1 2 3 4 5 शिफ्ट बाई 5 किया तो देखिए ये तो इससे मैच कर रहा है, ये भी 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 इससे मैच कर रहा है और ये भी इससे मैच कर रहा है, पर ये तो नहीं मैच करना चाहिए, तो इसलिए ये भी यूजलेस हो गया। ठीक है, तो अब हम कितने से शिफ्ट करेंगे? 6 से कोशिश करेंगे। पर 6 भी बेकार है, राइट? राइट, सो 6 से शिफ्ट करने पर भी बेकार है, 7 से शिफ्ट करने पर भी बेकार है, 8 से शिफ्ट करने पर
भी बेकार है, 11 बराबर हो जाएगा।
8 से शिफ्ट करने पर भी बेकार है। एक सेकेंड, तो यहां कुछ गड़बड़ हो गया, राइट? वी वुड लाइक टू इलेवन से शिफ्ट हो सकता है, राइट? तो यहां पे दो पॉसिबिलिटीज हैं, राइट? या तो हम इसको भी यूजलेस डिक्लेयर कर दें, किसको? 5 को, राइट? या इसको हम यूजलेस ना डिक्लेयर कर रहे हैं, इतने से शिफ्ट करके चेक कर लें। एक्चुअली
टेक्स्ट कंटेन्स एट 11th one. पता है
we know in a certain way, right?
Does not contain it.
Okay, so I'm making a small mistake here, because I want it to work at 6, right? See? So let me change this. Let me make it 12. Right? Actually, I want to make I plus 1 equals 12. So 12 is the first place at which the mismatch occurs. तो 11 तक मैच कर रहा है, तो तब 6 पर it's okay, sorry, 5th is okay, right? Because A B A B A और यहाँ B आना चाहिए, which is not the same as this, right? So this is acceptable because हमने कहा 12 पे मिसमैच हो रहा है, यहाँ पे मिसमैच हो रहा है, तो यहाँ पे A नहीं होगा, तो यहाँ तक का तो ठीक है, ये तो A है, पर यहाँ पे A की जगह कुछ और है मतलब कुछ भी हो सकता है। तो हम ये चाहेंगे कि शिफ्ट होने के बाद ये वाला पार्ट जो है ये ना हो सेम, ठीक है? सो वी विल से दैट 5 इज अ रीजनेबल वैल्यू टू शिफ्ट बाय। सो h I of 11 or h of 11 or the 11th location of this array would be, okay, we'll come to what it is exactly. So I have defined hi to be the length of the longest proper suffix of p1 through pi that matches the prefix of p. Okay, now let's understand what this is. What is the suffix of p1 through pi? So what is, okay, let me pick up a different pen now so that I can continue to make this dirty. Okay. ठीक है, एक सेकेंड, let's erase some part so that we have space. Great. Great, and now recall we said this would also be an A. Okay, sorry, I need a wrong color. Okay, ये A है, ठीक है, और यहाँ पे mismatch है. So P1 through Pi is this part of the pattern. What is the suffix of P1 through Pi? Suffix, you know suffix, you know prefix? Prefix is before, contiguous parts before. So A is a prefix, AB is a prefix, ABA is a prefix, ABAA is a prefix, and so on. And what are suffixes? A is a suffix, AB is a suffix, AABA is a suffix, ABAABA is a suffix, and all. So I am finding the longest proper suffix. Proper suffix? Proper suffix means suffix which does not include the entire text. Like proper subset means strictly smaller, right? So strictly smaller suffix. So that's what proper suffix of P1 through Pi means, that matches a prefix of P. Right? So I have to find out the length of the longest suffix of P1 through Pi that matches a prefix of P, which is exactly this. This is the one we showed here. Right? देखिए क्यों? Why should a suffix match a prefix of P? Because when we shift it, it's the prefix of P which comes towards the suffix. Right? And I have to find the longest match, because that determines कि कितना मैं shift कर सकता हूँ without leaving out, without missing out on a possible match somewhere. So I have to find out the longest possible match, and then there is this additional condition that the I plus 1th character, so I is the length, so I am finding out hi is the length of the longest such suffix which matches the prefix of P, and then I want that I plus 1th character of this should not be the same as the hi plus 1th character of the pattern, because hi, this quantity is hi now for us. This quantity is hi. So hi then is 1, 2, 3, 4, 5, 6. So I don't want that the 7th character of the pattern, this is what is this saying, P7 should not be the same as P12. And why did we require this? Because we know that there is a mismatch happening here. So we want that they better be different. So this is the definition for our hi. So it's a bit of a tricky definition, but you understand what the argument is. Right? So what is hi? So it is not really how much you are shifting by. Right? So it is determining ki hi is saying ki h, so here we were computing I is 11, we were computing h11. So we are saying if the pattern has matched the first 11 positions, then h11 says that okay, if there is a mismatch at the next position, then what is the shift? So after the shift, how many characters still continue to match? So after the shift, how many characters continue to match? 6 characters. Right? And what is the extent of the shift? 11 minus 6, 5. Yes? Right? The logic is very simple. You are trying to determine what is the extent to which you can shift the pattern. You are trying to determine what is the smallest extent by which you can shift the pattern. Right? You will say smallest is 1. But smallest is not 1 because 1 is quite meaningless. Shifting the pattern by 1 is not, you know that clearly there will be mismatches happening. So what is the smallest extent by which you can shift the pattern without doing unnecessary work? You don't want to kind of, if you know that there are certain mismatches happening, so you want to figure out the right extent to shift, but you don't want to shift by a huge amount either. Why didn't I shift it by 11 units altogether? Because then I would have missed out on certain possible matches. Yeah? नहीं आया समझ में? ये आ गया भाई वाह. Okay, so let's continue. So this part of the pattern, this is what we already discussed, is the same as this part, right? And 7th position is not the same as the 12th position. So which means that with hi की value, अगर हम h11 की value 6 डालते हैं, so then this condition is true. This would be 7th. The 7th position is not the same as the 12th position. I is 11 and hi is 6. So h11 की value जो है इस तरह से 6 आती है. ठीक है? क्या नहीं समझ में आ रहा है? Okay. Now, if there is no proper suffix of P1 through I with this above property, then what should the value of hi be? what is HI capturing? HI is capturing कि shift करने के बाद कितने part continues to match. Shift करने के बाद if no part continues, अगर कोई इस तरह का नहीं है suffix तो no part will continue to match. So उसकी value 0 हो जाएगी. इसका मतलब कितने से shift करेंगे? सीधे I से. ठीक है? Okay, so let's take some examples and then this will be clear, right? So this is my text, this is my pattern, and where is the mismatch happening? C और A पे यहाँ mismatch हो रहा है, ठीक है? तो this is position 12 of the text, ठीक है? So till 11 positions match has happened. So I की value again 11 आ रही है, right? H11 हमने क्या देखा था? 6, ठीक है? तो अब हम कितने से शिफ्ट करेंगे इसको? 11 minus 6, 5. So that's what is happening. ये जो लास्ट 6 कैरेक्टर्स हैं इस पैटर्न के, इसको तो छोड़ दीजिए क्योंकि यहाँ मिसमैच हुआ. जो लास्ट 6 कैरेक्टर्स हैं पैटर्न के और जो फर्स्ट 6 कैरेक्टर्स हैं पैटर्न के वो सेम है. Right, red in the same direction, not red like this and this, right? So last 6 characters and first 6 characters are the same. So you can actually move the pattern all the way up to here. And further, this is different from this. So there is a potential that this guy matches with this. It does not, that's a different thing. But there is a potential that this guy matched with this. So we'll shift it by so much amount. Right, so this is a shifted pattern. H11 is 6. Right. So we are shifting P to the right so that P1 through HI, right, 1 through 6 aligns with the suitable suffix of, with this as the suffix of the text. So K is the position of mismatch, K minus 1 is the before this and K minus HI is this part. So it aligns with this perfectly. Right, and these parts should match. Why? Because this is the same as this, which is the same as this. So they match. So in other words, we are shifting P I minus HI places to the right. If there is no mismatch, suppose the pattern was was only up to here. Okay, this was not part of the pattern. AB was not part of the pattern. So that means that till the 11th position, everything matched, everything is fine. How much should I shift forward by? Huh? Again the same I minus HI, right? Because by doing that we would not be missing out on any other patterns then. So everyone understands why we are looking at the longest such matching part? So that minimum shift occurs or maximum shift occurs? So that minimum shift occurs. That way the minimum amount of shift is happening. And but why did we want a minimum amount of shift? We wanted the largest possible shift, right? So the right answer should not be so that minimum shift occurs, so that we don't miss out on any patterns. That's why we are looking at the longest prefix, so that we don't miss out on any one at all. If I were to take a shorter prefix, I might end up missing out on some guys. Okay. Why does this work? Right? Why is it that we are not missing out on any patterns by doing this? Right? We have to argue correctness of this algorithm. So this is my piece of text. Mismatch was at position K of the text and position I plus 1 of the pattern. This is the position I plus 1 of the pattern and this is the position K of the text. In this case, K and I plus 1 are turning out to be the same, but there could be some part of the text even before this, in which case I plus 1 and K would not be the same. This is before the shift, and this part, these 6 characters were the same as these 6 characters, which is why we could move it this way. Yeah. So this is the situation after shift. right. So, if this part is beta, then this part is also the same as beta, this substring. Okay. So, suppose this was not the case, that is the KMP algorithm missed out on certain patterns. There were certain patterns in the text which we could not find by this procedure at all. We will argue that such a thing cannot happen, right. And suppose there is this missed occurrence of the pattern. ये एक pattern का part था जो इससे text से match करता है, मतलब these are the same as these, but we missed out on this one, right. हो सकता है ऐसे, हमें प्रूव करना है कि ऐसे नहीं हो सकता, पर हम प्रूफ बाय कॉन्ट्रडिक्शन कर रहे हैं. सपोज ऐसा है, सपोज ऐसा है कि ये एक मिस्ड अकरेंस ऑफ पैटर्न पी है जो हम नहीं रिपोर्ट कर पाए. क्यों नहीं रिपोर्ट कर पाए? क्योंकि हमने इसको सीधे यहां से यहां शिफ्ट कर दिया. ठीक है, ओके, देखते हैं फिर क्या होता है. फिर ये वाला वो मिस्ड अकरेंस है, तो ये वाला पार्ट विल बी द सेम एज, अगर ये अल्फा है तो ये वाला पार्ट भी अल्फा हो गया टेक्स्ट का. अगर ये वाला पार्ट अल्फा है तो ये वाला पार्ट भी अल्फा हो गया, क्योंकि ये वाला यहीं पे मिसमैच हुआ था. This guy mismatched only at this, so this has to be the better be the same as this. So this is also alpha, right? And so these alpha characters, this prefix of the string of length alpha matches a suffix of p1 through pi of length alpha, and alpha is more than beta. So this violates our definition. Yeah, right. So alpha is more than beta, which is hi. So that is, and furthermore, there was one other condition that we have, that this character, देखिए, we also required that this character, अब आप ये कह सकते हैं कि well this matches, these are longer, this matches this is a longer prefix. Yes, agreed, but well this character is also the same as this, इसलिए हमने इसको नहीं कंसिडर किया. ये भी तो आप कह सकते हैं. देखिए उसमें दो कंडीशन थी, है ना, पर ये कैरेक्टर और ये कैरेक्टर अगर सेम है तो ये भी वही हो गया, क्योंकि अगर ये पूरा पैटर्न इससे मैच कर रहा है, ये पूरा इससे मैच कर रहा है, तो ये पिंक कैरेक्टर ये पिंक कैरेक्टर है, और अगर ये और ये सेम है तो इसका मतलब ये और ये भी सेम हो गए, राइट. सो पी एल एंड पी आई प्लस वन, हम ये कह रहे हैं कि पी एल और पी आई प्लस वन सेम है, जिसकी वजह से हमने इनको नहीं लिया था. सो पी एल इज इक्वल टू टी के बिकॉज दे मैच्ड, टी के इज नॉट इक्वल टू पी आई प्लस वन बिकॉज देयर वाज अ मिसमैच, and so PL is not equal to PI plus 1, and so it could not be that this and this were the same, for which reason we did not take this longer suffix or prefix or whatever you want, right. So it is also the case that this and this are different. ये एक requirement थी, you remember? Yeah. Should I go back to the previous slide? Right, this was one requirement we said, right, कि we are looking for the longest prefix which matches a suffix of p1 through pi, and pi plus 1 is not equal to p of hi plus 1. Both the conditions need to be satisfied. आप ये कह सकते हैं कि वेल ये तो लॉन्गर प्रीफिक्स है, ये ठीक है, पर दूसरी कंडीशन नहीं सेटिस्फाई हो रही है, तो मैं इस यहाँ पे ये आर्ग्यू कर रहा हूँ कि दूसरी कंडीशन भी सेटिस्फाई हो रही है, तो इसका मतलब गड़बड़ है, आपने hi की वैल्यू ठीक नहीं ली थी, your hi value was not correct, right, and this establishes the correctness of the algorithm. So if you had the correct values of hi, then this thing would work fine. Okay, question so far? So let's take an example, and this would now be clear after this. So I have a certain pattern, 13 character long. This is the input string. Well, you can't see the input string most likely, but don't worry, we will expand it out. And this is the array H. Suppose I have calculated it in some manner, right? Array H can be calculated, right? For every I, you can, with some amount of effort, figure out what H of I should be. We'll see how to do that also, right? So suppose I have figured this out. For instance, it's the same pattern. At 11, you have 6, right? Let's see how we are going to use this information. Let's do a complete example now. So this is my pattern, this is the text, the first mismatch occurs at position 12, right, which means till position 11 there was a match. Position 11 there was a match, so I go to position 11 in the array, I see a 6 written there. There is a 6 written at position 11, so what does that mean? I have to shift by 11 minus 6, 5 units. This 6 is telling me how much of the pattern is going to remain matched after the shift. So 6 characters of the pattern will remain matched. और अभी तक 11 characters matched हैं, तो 11 कितना shift हुआ? 11 minus 6, right? So H11 is H11 is 6, so I minus HI is 11 minus 6, which is 5. So I have to shift by 5 units. So I do that. I shift by 5 units. As you can see, 1, 2, 3, 4, 5. The pattern has been shifted by 5 units. The pattern is the one on top, the text is below. Now again, I continue to look at this position. Note that I don't have to try and match these first 6 positions, because they I know are already matched by the definition of the function h. They are matched, nothing to be done here. But this 12th position ये जो थी, इस पे पता नहीं मैच हुआ है कि नहीं, फिर से देखते हैं इसको, हुआ है नहीं हुआ है, तो इसका मतलब अभी भी मिसमैच हो रहा है इस 12th पोजीशन पे. 12th position of the text, but what position in the pattern is it? This is position 6, 7 in the pattern. At I की value 6 है, right? Mismatch 7th position of the pattern पर है. I की value 6 है. Now I go to 6 and I see यहाँ पे 3 लिखा हुआ है. So H6 is 3. Right? So now I am going to shift by I minus H6. 6 minus H6, 3 units. 6 minus 3. 3 units I will shift. Right? Because there is still a mismatch. So that is what I do. I shift by an additional 3 units, and this is the situation I have now. Right? ये A, B, A आ जाएगा. Right? A, B, A. अभी भी मिसमैच है, अभी भी मिसमैच है. अब मिसमैच यहाँ पर 4th पोजीशन में है पैटर्न के. टेक्स्ट का पोजीशन वही है 12, हम उसके आगे अभी तक बढ़े ही नहीं है, बढ़ भी नहीं पाएंगे. यहाँ C है पैटर्न में, कहीं C है ही नहीं. ठीक है ना. पर देखते हैं अब क्या है. I की वैल्यू क्या हो गई हमारी? 3 हो गई. तो वी गो बैक टू दैट अरे. उस अरे में 3 पर H3 1 था, which means that we have to shift by 2 units to the right. So we shift 2 units to the right, and so we will get A, B. After the shift we will get A, B and something, but B and C still mismatch. So I की वैल्यू अब क्या हो गई? 1. H1 की क्या वैल्यू थी? 0. Right? Which means we will now shift by 1 unit. A and C mismatch, so we will shift by another 1 unit. क्योंकि I की वैल्यू तब 0 हो गई. राइट? तो इस तरह से आपका ये चलता जाएगा. When you shifted beyond this C, then there was a match found, and you found a match. क्या नहीं समझ में आ रहा? Right? So if you had this H function, you can use that to determine how much you should shift by at every step, right? So that a match can be found. And this shift function is designed in such a manner such that you will never miss out on any potential match. Right? Right? Everyone followed this 210 business? Calculation of H. Okay, we come to that also. How much time does our algorithm take? Suppose H is given to you. We will see how to do the H. Suppose H is given. तब हमें कितने, we will count the number of comparisons, let's say. कितनी बार हमें 2 characters को compare करना पड़ा? At most?
Because every time we are at least moving by 1.
देखिए यहाँ पे लेट्स से सब कुछ पहले हमने एक एक कंपेयर किया. यहाँ पे this was the first step at which we had a mismatch. तो मतलब ये हमने एक कंपैरिजन किया और ये वेस्टेड कंपैरिजन हो गया. वेस्टेड मतलब बिकॉज इट डिड नॉट रिजल्ट इन अ मैच. तो फिर हमने शिफ्ट किया. शिफ्ट करने के बाद हम फिर से इसको कंपेयर करेंगे, फिर से एक कंपैरिजन करना पड़ा. तो हम ये आइडेंटिफाई कर रहे हैं कि हमें टेक्स्ट के एक कैरेक्टर को कितनी बार कंपेयर करना पड़ेगा. कई बार कंपेयर करना पड़ सकता है. देखिए यहां तो 2 बार हो ही गया इस कैरेक्टर का, ठीक है, पर हो सकता है अब हमने फिर से शिफ्ट किया तो जैसे हमारे पिछले एग्जांपल में हो रहा था, वो सी के आगे बढ़ ही नहीं पा रहे थे, तो वो सी से ही बार बार कंपेयर कर रहे थे. every time we were comparing with C. So how many times could we be comparing with a certain character? Many times, right, up to length of the pattern. But that doesn't sound very good, right, because that would mean that the number of comparisons is huge. For each character the number of comparisons, the maximum number of comparisons could be large, but let's look at the total number of comparisons put together, right. So let's call these unsuccessful comparisons. What is an unsuccessful comparison? A comparison that results in a mismatch. Okay, let's call that an unsuccessful comparison. Now how many unsuccessful comparisons are there overall put together? देखिए, every time I do an unsuccessful comparison, I shift the pattern. ठीक है, फिर से एक अनसक्सेसफुल कंपैरिजन हुआ, अगर फिर से पैटर्न को शिफ्ट कर दिया. कितनी बार आप पैटर्न को शिफ्ट कर सकते हैं टोटल? At most the number of the size of the text types. So the number of unsuccessful comparisons is at most the size of the text, which is n, right. So unsuccessful comparisons are not too many. Successful comparisons कितने होंगे? देखिए, after we shift this, so these were all the successful comparisons. After I shift these successful comparisons, these characters were all part of successful comparisons. We will never compare against these characters again. हमने इनको कंपेयर किया एक बार, शिफ्ट किया, तो तब हम दोबारा नहीं कंपेयर करते इनको, क्योंकि वो तो हमें पता है कि ये मैच्ड है. ठीक है, तो हम इस पैटर्न को बढ़ाते जाएंगे, पर हम वी विल नेवर कंपेयर दिस पार्ट ऑफ द पैटर्न, द पार्ट बिलो बिफोर दिस रेड लाइन विद द टेक्स्ट. So each character of the text which is ever part of a successful comparison is compared only once. There is no backtrack happening. We don't ever go back, right. So the number of successful comparisons is at most the size of the text. So the total number of comparisons is the number of shifts plus the number of successful comparisons. Number of shifts, why? Number of shifts was the number of unsuccessful comparisons, right. So we broke up our comparisons into two sets, successful and unsuccessful. A successful comparison, once you make a successful comparison, once a character is part of a successful comparison, it's never compared again. If a character is part of an unsuccessful comparison, it might be compared again, right, but it results in a shift. So every unsuccessful comparison results in a shift. So total number of shifts, since it can be no more than the size of the text, total number of unsuccessful comparisons can be no more than the size of the text. So the total number of comparisons therefore is at most 2 times the size of the text. ठीक है? So this is the complete thing actually, right? So total number of comparisons that are required is the size of the text. But what about computing the array H? How do we compute the various HIs? And how much time does that take? Right? So we are going to call that pre-processing time. Okay? So recall that the size of the pattern was m. The size of the text was n. What one can argue is that the time required to compute the array H is only order m, the size of the pattern. And the time required to do the searching we just saw is order n, the size of the text. So, the total time therefore is order m plus n. Okay. This part is, I have not told this to you yet. Why is computing the array H, why can it be done in order m time, right? Let us see why. So, I am going to, so we have to compute array H. Right, and what was our definition of array H? So, suppose I have to compute H of I look at my pattern, right. So, I have a certain pattern. This is the ith position, right. What is H of I? Who can remind me what H of I is? The longest proper prefix of the pattern, which is also a suffix of 1 through I, and the next characters have to be different. Okay? So, hi ki value, it is the longest suffix, longest prefix or the longest suffix, whatever, longest prefix of the pattern. So, what are the potential values of hi? What are the different values hi can take? 0 to m, 0 to 0 to I minus 1, because we also said proper. Proper, what is a proper subset? When is a subset proper? When it is not equal to the set. So, that is what a proper suffix is, right, when it is not the entire string. Okay. So, essentially it can take I different values, give or take a 1, right, and I can try out all those various values. What does that mean? Suppose I am trying out the value hi equals 3. What should I do to try this out? Right, I should look at the last 3 characters here, yeah, and the first 3 characters, and see if they are the same. If this is the same as this, if this is the same as this, and if this is the same as this, then hi can be 3. Yeah, then hi is more than or equal to 3. So, I will try out 3, 4, 5, 6, 7 all the way up to I minus 1, and whichever are the possible values, I just take the largest amongst them, right. Clear? So, how much time does this take? So, how much time do I take to compute hi? I will try out all the I different values, I will do all these so many comparisons, yeah. So, in particular if I choose a value of hi equals j, then how much time do I need to do to check whether j is a candidate value? J time. So, I will take j going from 1 through I minus 1, 0 through I minus 1. So, this is I squared roughly. So, for hi I will take I squared time. So, for the entire array H I will take summation I squared, I going from 1 through m, which is m cube time, huge amount of time. Yeah, this should be O of m cube. Divide what by I?
You have taken it over all possible values of j. So should it be divided by?
Sorry? No, average नहीं ले रहे, right? We are just computing the total time required, huge amount of time, right? So we want to do something better.
Values of hi which are calculated.
We can use the previous values of hi which have been calculated. How can we use that? Right. So that's a very nice idea. In fact, that's the right idea. So to compute hi, so we are going to assume the following. That when you are trying to compute hi, you already have The previous values, h1 through hi minus 1. These are already there. Note that in doing this computation of array H, we do not require the text at all. It is being done just on the pattern. Okay? So, you can take your pattern, you compute your H, and then you can match it against whichever text you want. Right? So, the text can be whatever you want. Once you have computed this, then you can just go ahead and work with the pattern, with the text. Okay. Now, suppose, so I am trying to compute hi again, and I know all the values of h1 through hi minus 1. How can I use these to compute hi? Who can tell me?
Like we did
Span of a stock using a stack. Okay, lots of S's. Okay, now why? What can we do? I don't think that's the same idea, but can someone tell me what should I do here?
maximum can find out
Max of the values is contained in I.
So if we have hi minus 1,
Contains the max value.
we can take value of hi minus 1, we know this matches with this. So we can start.
For hi minus 1 we know, okay, so if hi minus 1 was, let us say 5,
So the first 5 matches.
so we know that the first 5 match with these 5, right? So these
Just
5,
take the next one.
these 5 match with these.
You know the first 5 matches.
Right. So, these are the first 5 of the pattern. This is the pattern P, this is also the pattern P. So, the first 5 of the pattern match with I minus 1, I minus 2, I minus 3, basically I minus 5 to I minus 1 of the text of the pattern itself. Right. Now, how do I know what hi is? Sorry, this does not solve my hi problem. Right. Now, if the 6th character of the pattern matches this, then can I say that hi is equal to 5? Hi equals, sorry, 6. Can I say that? Why not? Huh? So, I claim the following. If hi equals, yeah, P6, not hi, sorry, P of, if P of I equals P of 6, the 6th character of the pattern.
So it will never occur because we have ensured that the next one element is next one element के different होता है. Because the
They
next
can't be
element
equal, they have to be different. They have to be different by so for I minus 1, so the next don't match.
So we know that it is at least h of I minus 1.
It is at least,
H of I minus 1. Hi is at least.
So if it is 5, then
pardon?
So it will be at least h of I minus 1. So we will try that, assuming that it is at least 5. So we try after that value.
Right. So, that is what we have to do. We have to do something like,
sir, it can't be 5.
because we ensured that the element should not be equal to the next
there was zeros also. Yeah. So, it need not be an increase. No, but it need not be equal to hi minus 1. It could be 0 also. We are saying, but it could potentially, if this and this match now. So, I am sorry, I am confusing my array H with my.
Definition of hi. So hi of I plus 1 is not equal to hi plus 1.
So check for I minus 1, the last condition.
By the definition of hi minus.
Right. So, they would not match.
Will not match. So it has to be less than 5.
Or greater than 6. Or greater than 6.
Okay. So, that is a good question. We will take this up in the next class. Yeah. So today we looked at pattern matching in a text. So we looked at a very simple algorithm for doing that, which had an order mn time. Then we looked at the Knuth-Morris-Pratt algorithm, which we argued has a running time of order m plus n. So that was the improvement. We went from mn to m plus n. This is modulo the fact that you can compute the array H in order m time. So we've shown you how to compute the array H in order m cube time, and we are going to see how to do that in order m time in the next class.